This video is for those who are looking for a bit of an extension. I already have my page set up and my date in the top right corner. The topic is also listed here, and it is calculating outliers. The essential question for this video is, how do I calculate a statistical outlier mathematically? Let's first remember that outliers are pieces of data that don't seem to fit in with the majority of the other pieces. We've said before that we find these by looking at what doesn't look like it belongs. However, there is a more specific way to calculate this, right, other than just looking at what sort of doesn't fit in. To do this, we need to find the interquartile range. That's going to be important in this video. If you don't remember the interquartile range, look at your notes from our video on quartiles, or rewatch the video if you need a clarification. As a quick reminder, the interquartile range is the difference, when subtracted, between the upper and lower quartiles. Statistically speaking, an outlier is any data point that is more than 1.5 interquartile ranges below the first quartile or above the third quartile. That might sound like a kind of mumbo-jumbo, so let's see what it means, what the steps are for interpreting that, and then how we can apply that to find outliers in a set of data. The first step to finding a statistical outlier will be to find the IQR, the interquartile range. The second step will be to take that IQR and multiply it by a value of 1.5. Because remember, we're looking for things that are beyond 1.5 times smaller or larger than our interquartile range. The value we get here is going to be used 2 times. The first thing you'll do with that value is to add that to your upper quartile. You will also take that product and subtract it from the lower quartile. These 2 numbers that you have just found represent the boundaries of what is considered the outlier. Let's try it with a data set. I'm going to turn my page and give you a set of data to work with. So here we have a data set that we're going to use to find the outliers. You can see this data set ranges from 5 up to 26. Luckily for us, these are already listed in numerical order from least to greatest. If they weren't, of course, we would have to rearrange them and make sure they were in order of least to greatest. Otherwise, we wouldn't be able to find our median and quartiles. Okay. Before we begin, I want you to take a moment to make a prediction or a guess of what we think the outliers might be. Right? Just looking at these, what do we think our outliers could be? And we'll come back at the end and see if we were accurate. Okay, now that I have my prediction, we're going to go ahead and get started. So the first thing we need to do is to find our interquartile range, which means we have to do 3 things. We have to find our median and our upper and lower quartiles. If I look for my median, right, I'm looking for my middle number, go ahead and mark off your middle number. I see that in here we have an odd number of pieces of data, and so we have 1 middle number, and that happens to be 12. Once we have our median, we're going to look for our lower and upper quartiles. So I'm going to start first by looking to the left and looking to see what is the halfway point of the first half of the data. So I can see to the left of the median there are 4 numbers, which means the middle is right here in between these 2. Right? And in between 10 and 10 is still 10. So this is my lower quartile. I'm going to do the same thing looking to the right to find my upper quartile. I have, again, 4 numbers to the right. I'm going to look in the middle. This time it's between 14 and 18, and halfway between 14 and 18 is 16. So 16 represents my upper quartile. From there, we need to find our interquartile range, right, which is the difference between our upper quartile, which is 16, and our lower quartile, which is 10. Our interquartile range is 6. So that was all step 1, right? That was all just finding our interquartile range. Now we're going to take our interquartile range and we're going to multiply our interquartile range by 1.5. Okay, so in this case, we're going to be multiplying 6 times 1.5. When we multiply 6 by 1.5, we should get a value of 9. According to our steps on the previous slide, once we know our interquartile range and we've multiplied it by 1.5, we have to add that to our upper quartile. So our upper quartile was 16, and remember when we multiplied our IQR by 1.5, that was 9. So if I add those together, I get 25. The next step, or the last step really, was to take our answer of our interquartile range times 1.5, which was 9, and subtract it from our lower quartile. So our lower quartile was 10. We're going to subtract it by 9, and we get 1. These two numbers that we found, 25 and 1, represent the boundaries that indicate where outliers are. So anything that is above 25 now is considered an outlier. Anything less than 1 would be also considered an outlier. But anything in between those two falls perfectly within the realm of what we would expect for a typical piece of data. So in this data set, if we go back to our top data set, we might have thought that the 5 was going to be an outlier, right? Because it looks a little bit less than everything else. So we might have just assumed that was going to be an outlier, but statistically speaking, it's not, right? Because it is greater than 1, and things had to be less than 1 to be considered an outlier. Our guess of 26 would be accurate, however. 26 is greater than 25, and 25 marks the boundary beyond which numbers would be considered outliers. So in this case, anything that is greater than 25 would be an outlier or less than 1. Right? So there we have it. That's how we statistically calculate outliers. Go ahead and ask yourself if that makes sense. Rewatch anything that might be confusing. Try it out with a data set of your own. Right? The essential question was just trying to figure out how we can statistically calculate outliers, right? How we can use a mathematical formula for that.